This video will cover methods of solving and complex operations. I'm going to go through it pretty quick. You can certainly pause it along the way if you need. Standard form of a complex number is a plus bi, where a is the real and b is the imaginary. I imaginary. And just a reminder that I is the square root of -1. So if you have a negative under the square root, instantly it's an I. You can add and subtract and multiply and divide real numbers, and it's really pretty straightforward. Combine like terms. So think of it as an x. 11 plus 3x plus 9 plus 2x, you would combine the x's. 11 plus 9 is 20. 3i plus 2i is 5i. Literally, that is it. Move on. You're just combining like terms. The next one, same thing. It's going to be 4 plus 7, which is 11. I plus -5i is -4i. That is it. Move on. Okay. We can multiply complex numbers. So 2i times 8 is 16i minus 2i times 3i is 6i squared. But now we have an issue. If you square the square root of 2, you get 2. When you square a square root sign is reduced out. If you square the square root of 6, you get 6. So if you square the square root of -1, you get -1. Square a square root sign goes away and you get -1. Well, what's the square root of -1? The square root of -1 is I. So if I substitute and take out root -1, and I put I in, that's I squared is -1. I squared is -1. So you are not allowed to leave I squared in your final answer. This is 16i minus 6. Take out I squared and put in -1. That becomes plus 6. Okay. So I'm going to distribute. 2 times -5 is -10. Some of you learned it as FOIL. 2 times -3i is -6i. -4i times -5 is plus 20i. And then plus 12i squared. Again, if you need to, pause the video. So -6i plus 20i is positive 14i. 12i squared, that's 12 times -1. I squared comes out, -1 goes in. This is -12. So you get a total of -22 plus 14i. That's supposed to say subtraction. 6 minus 2i squared is 6 minus 2i times 6 minus 2i. So that distribute and you get 36 minus 12i minus 12i plus 4i squared. So this becomes 36 minus 24i. I squared comes out, -1 goes in. So this becomes -4. 36 minus 4 is 32. All right. Number 6, I'm distributing and combining like terms. So I'm going to distribute 1 times 9 is 9. Plus 3i, I'm distributing. 7i times 9 is 63i. Plus 21i squared. And then I'm subtracting this whole quantity, so it becomes minus 4 minus 2i. Minus 4 minus 2i. Think of that as a negative 1 distribute. Okay, so we have 9. 3i plus 63i is 66i, minus 2i is 64i. And then we have 21i squared, so that's 21. Take out the negative, sorry, take out I squared, put in negative 1. I squared comes out, negative 1 goes in. So this is negative 21. So I have 9 plus 64i minus 21 minus 4. 9 minus 21 is 12. Negative 12 minus 4 is negative 16. Nine minus 21, 9 minus 10, 11. So that's 12. Yeah. Okay. All right. So this next sheet, which is methods of solving, this is fantastic review for your final exam. No matter which method you choose, you should get the same answer. No matter which method you choose, you should get the same answer. All right, not all these methods always work. Sometimes when you graph, you might get imaginary. So if you recall, I said, well, sometimes the graph is above and it doesn't touch the x-axis. How are you going to solve for that? Or maybe the vertex is below and doesn't touch the x-axis. So you can't always solve by graphing. Not everything is factorable. Square roots, special, but you can always solve by completing the square. Completing the square always works. It's not necessarily pretty, and the quadratic formula always works. Completing the square and quadratic formula always work. Not everything's factorable. For square roots, b must be 0. If b isn't 0, can't do it. So we're going to go through each one of these methods and solve, and we should get the same answer. Okay, graphing. Opposite of b over 2a. You have two choices. Opposite of b over 2a to graph, or complete the square, and you would put it in vertex form. Well, when I complete the square, I'm going to put it in vertex form, so why would I do it twice? Opposite of b over 2a. Let's just write this off to the side. A is 1, b is 6, c is 5. No matter which method we use, this is the case. A is 1, b is 6, and c is 5. Okay. Opposite of b over 2a. So negative 6, 2a is 2. The vertex is at negative 3 something. All right, I'm going to draw on my axis of symmetry. 1, 2, 3. This graph is very, I don't know about you, but sometimes if I look at it for too long, and it all gets blurry and looks the same. Let's plug in negative 3. Negative 3 squared plus 6 times negative 3 plus 5. Why am I doing this? Because it's going to tell me the y-coordinate of the vertex. Fantastic review for the final, and this was on your test. 9 minus 18 plus 5, negative 9 plus 5 is negative 4. So the vertex is at negative 3, negative 4. All I did was plug in. I know I'm going fast. If you need to, you can pause the video. Is that right? I hope so. 1, 2, 3, 4. Yeah. I can't just draw the graph wherever I please. Like maybe it's really wide. Maybe it's super narrow. All right, so let's find the y-intercept. Do you want to find the y-intercept of any function x is 0? If x is 0, you get 0 plus 5, which is 5. 1, 2, 3, 4, 5. Reflect it over. So from the axis of symmetry, I have moved 3 to the right, and then we're going to move 3 to the left. Okay, so I'm going to connect the dots as best I can. Okay, and just looking at it, so remember the zeros, the x-intercepts, they all mean the same thing. Just looking at it, I would say that the x-intercepts are maybe at -1 and -5. Perhaps just kind of eyeballing it. Okay, well, we'll solve by the other methods and see if that's the case. So let's check out factoring. Okay, well, when I solve a problem by factoring, the shortcut is to see what's the discriminant. And if the discriminant, b squared minus 4ac, is a perfect square, then I'll know it's factorable. So then I don't have to waste my time trying to figure out the diamond, whatever. So let's check the discriminant. And you know what? The discriminant, b squared minus 4ac, is part of the quadratic formula. So I'll like be halfway done with the quadratic formula. So it's not like it's a waste of my time. Okay, so b squared minus 4ac. So b is 6 squared minus 4ac. Now there is no doubt that some of you are good enough at factoring where you don't need to do the discriminant, you can just tell, and that's fine. But the discriminant is certainly a good thing to do. Plus it tells you how many solutions. So this is 36 minus 20, which is 16. This means that the graph has 2 real solutions. Doesn't it have 2 real solutions? Look at the graph. 2 real. The discriminant is 16. That's greater than 0. Okay, it's a perfect square. So that means the problem is factorable. If you need to, look back at your notes from either Monday or yesterday. It tells you a lot about the discriminant. Okay, so AC is 5, B is 6. What multiplies to 5 but adds to 6, I believe, is 1 and 5. A is 1. A is 1, so we can shortcut it. X plus 1, X plus 5. X plus 1 equals 0. X plus 5 is 0. X is -1, -5. Well, that's a good sign. We got -1, -5 by eyeballing the graph. X is -1, -5. Fantastic. Okay, so we should get the same answer now by using square roots. Really? I don't think I need to use square roots, do I? B must be 0. B must be 0. Well, is B 0? I don't think so. B is 6. B is 6. So for this particular problem, this is not possible. For this particular problem, it is not possible. Well, what do you mean it's not possible? Because some of you think it is. This is what I see a lot, and it's not correct. And I think that seeing the incorrect way is helpful. So many of you will start this way, and then you'll move the 5, and that's great. Okay, great. But then I see this. And you'll say that's X plus 6, and that is not true. You can only use square roots if b is 0. All right, you can always complete the square and you can always use the quadratic formula. Always works. Okay, completing the square. And this is nice because a is 1. So to complete the square, move c to the other side. Half of b squared is 3 squared, and that is 9. Add it to both sides. Factor, what did you square to get 9? You squared 3. I like that. I see 4. 4 makes me happy. 4 is a square, perfect square. All right, I'm going to square root both sides. This is allowed. Can you square root a square? You sure can. That gives you x plus 3 equals plus or minus 2. Do not forget the plus or minus sign. Subtract, so you get x equals negative 3 plus or minus 2. Negative 3 plus 2, negative 3 minus 2. And guess what? I think that's going to be negative 1 and negative 5. Negative 1, negative 5. This wasn't possible. Negative 1, negative 5. Pretty close. Negative 1, negative 5. Quadratic formula, which I think for many of you, that's your preferred method of solving. Okay, so quadratic formula, opposite of b, plus or minus, square root. We already did b squared minus 4ac, didn't we? B squared minus 4ac was 16. Fantastic. I'm not going to redo it. Opposite of b is negative 6. 2a is 2. You cannot reduce negative 6 over 2. No. You've got to take care of the root first. So this is negative 6 plus or minus the square root of 16 is 4 over 2. This is negative 6 plus 4 over 2. Negative 6 minus 4 over 2. And guess what? That's negative 2 over 2, negative 1. This is negative 10 over 2, which is negative 5. And lo and behold, regardless of which method you use, as long as it's a legally, legal mathematic method, square roots for this problem was not a legal mathematical method. So if you see, or you can't quite see them all, but negative 1, negative 5, negative 1, negative 5, not possible, negative 1, negative 5, negative 1, negative 5. So it's important to know several methods.